Any questions? So, have you gone through the lessons up to now? Or all right, if you don't have any questions, I'll quickly go through the slides. Let me check. Shall I ask a question from you, or shall I share one in-class revision question with you? Probably that makes sense for you. Give me a second. As a quick revision, we'll do a few questions. I think probably you have gone through the subject like topics. So these are not something easy, right? So a little bit advanced topics are to be discussed in near future. So please be kindly enough to go through all the lectures before you join, and within 3 hours it's quite hard to learn all of these things. So the best thing is you should please go through a lot of online materials available, such as like YouTube and other stuff. So please go and refer as much as you can, unless you might get stuck once it comes to the examinations and other stuff. And once it comes to the quizzes, if I'm not mistaken, I can give one quiz for you. It's not a too difficult set of questions. Still, I haven't decided whether it should be a report kind of a thing or not, because once it comes to operating systems, it's more towards technical jargon that is supposed to work. So having a report is not something valuable or research kind of thing you can't perform still. So the best thing is having an online quiz kind of a thing, but I check the feasibility at the end of the semester, because we'll see. I'll let you know next week probably. All right, we'll do a simple question. Have shared the link in the chat. Yeah, Riaz, any questions? Riaza, right? Yeah, Riaz, any questions?
No, sir, sorry, sir.
Yeah, please feel free to start your answering. I'll give like 5 minutes just for a revision. And there's a plus point by completing these kind of in-class activities. You might get 5 points for each, right? For this in class activity. All right. So by completing this revision activity, you might get 5 points. So there's a point scheme for this for the lessons that I'm doing. Apart from the quiz, for the quiz you might get marks. For the revision activities and in-class activities and other stuff, you will get points. Importantly, right, the interesting story is if the assessments are insufficient, like your marks are insufficient to get to a good grade, what can I do is I'll add the points. I'll convert the points into marks, which is like extract same. 1 point equals to 1 mark. So earn as much as points. In any case, if you get lower marks in your assessments, for me, I can add these points into the marking scheme, marks. Then you will get more marks and you can get a good result. That's the importance of this scheme. So you might get more points than marks. So at the end of the day, if it is full of points, you don't want to bother, you'll get full marks for your assessments, right? Right, start. I'll give 5 minutes, I think. Network might be a little bit not stable for some reason, but don't get upset if there's something not clear for you. Please let me know. I can help you. All right. Yes, please submit the answer. I think that's more than enough time. It's very basic question actually. It's not hard question. Still, I got only 14 responses. 15. Quick, please. Won't spend more than that. All right. I'll keep another minute for you. All right. I think time is more than enough. So we'll start the discussion. I'll keep the link enabled so you don't want to bother too much. Even after the session, you may be able to answer. So we'll start the discussion now. All right. So last time we was discussed this process management. From the processes started from the new state, then it goes to the ready state, then it dispatches, and there's a running state. After the running state, there's a termination, which is the process being dead. And there might be different paths like start with the new process, then it ready, then it goes to the running state, then it moves to the falling or blocked state because of some sort of issue or some sort of resource requirement. After the resource is fulfilled, it goes back to the ready state, then it starts to running. Then it might be the dead. And there's a possibility to come right ready to running, then running to timeout, and it goes to back and forth until some situation, or it might be running throughout like blocking and other stuff. So usually if it is a lengthy process, there's a high possibility of all the processes being into the blocked state. uh, there might be some reason like having another resource requirement. Now, what do you mean by a resource? Anyone, please? What do you mean by a resource? Quickly. You may use the chat, no worries at all, right? You can chat if you don't like to speak. You may use chat, or you can use individually. You can respond to me. Yes, what do you mean by a resource? So resource can be simply your RAM, or your CPU, your processor, your battery, So all of these are resources, right? I think you can remember. If you can't remember, please make sure to follow all the things, because you know this some subject is quite hard than the others, I'm pretty sure. So please be like your maximum effort for this subject, unless you might be getting into trouble at the end of the day. All right, we'll continue the discussion. The process management, part of operating system that controls which process gets into run on the processor and for how long. Now, I'll take a real world scenario to explain the situation. Now, think there are a set of people or candidates for a job interview. So there are people in a queue. Fortunately, still you not, but near future, you may get this experience. You all will stay in a queue, but currently we have scheduling and minimizing these queues, right? So what happens? The job, the interview there. So one at a time, only one person can go to this chair. This is the chair, right? Okay, right. One person at a time, and this person asking question from one person only for a given time. It might be 10 minutes, it might be 5 minutes, for some reason it might be 20 minutes, but there's a specific allocated time. Now, whenever a person arrives to the queue, then this person knows who needs to go to the next, go to the seat next. Because if this person is in the front, then he knows, all right, I'm the next person to be going to the seat. Similarly, all of these candidates are ready to go to this seat. Now we'll map this story with the computer world. Now what happens in the computer world? Now here there are a lot of processors. There are a lot of processors. P1 process, P2 process, P3 process, such kind of processors are there. All of these processors are willing to go to the processing. Simply in generic terms, we'll tell it that's a CPU. P1 requires to go to the CPU, P2 willing to go to the CPU, P3 is willing to go to the CPU. All of these are willing to go to the CPU. Now they are ready. They have sufficient resources to execute. But CPU can process a certain process in a given time. It might be 1 millisecond, usually not. It might be 1 nanosecond. In real world scenario, it might be a 1 nanosecond in the processor. So what happens? P1 comes to the processor, process it. If there's something remain, what happens? It goes back to the waiting queue and let the next one join into the queue. Similarly, like this person goes to the queue, all right, this person has faced for the interview well, so ready to the next interview and waiting for another queue. Similarly, this process is okay, executed in the CPU and are waiting for another set of resources, another set of resources to be executed in the CPU. But P1 can't process forever, because there are processors waiting for the process. So what happens in the real world scenario? P1 starts executed and wait. P2 starts executed, wait. Everything won't wait. As an example, with the P3, it's a bare minimum, like 1 nanosecond of work. 1 nanosecond of work. So it jump into the CPU, execute, that's it. Then terminates. That's all. Now you know the process diagram, right? How it jumps here and there. You know the entire story of this. It starts, right? Then start, then execute, right? End, right? Here the waiting processes. So ready, running, but timeout, you go back into the running state. Running, this is the process state diagram. Okay, this is the process state diagram. Runs here, all right, wait, runs, wait, runs, wait, runs, wait. Up to a certain level or a certain resources are completed or the process is completed, what happens? It jump back into the end. That's how this process management happens. So that's the meaning of this sentence. Part of operating system that controls the process gets to run on the processor, and for how long? How long? There are different algorithms we are discussing in near future. What are these algorithms and other stuff? How long? There are like scheduling algorithms, shortest job first, first come first serve, round robin. So these are common algorithms. Now currently we have much fancy algorithms, but for a learner or a beginner, these are the basic algorithms that we can discuss. Processes are kept in a queue based on their status. Now what's the meaning of this? Processes are kept in a queues. Now all the candidates are arrived and all of these are waiting in a specific queue. All of these candidates are waiting in a queue. Similarly, all the processes are kept in a queue based on their status. How they what is the status of their arrival? As an example, this person arrived at the first time. This is the first interview. This person is the second interview. So they are two different states. And this guy comes to the marketing. This person comes to the HR. Then this is an IT guy. So different states are there. Different objectives, different reasons. Now we'll map the story into computer world. Think these are different processes: P1, P2, P3, P4 processes. So these are processes. Now what happens here? All of these processes are willing to run. All of these are in a proper queue. And based on their state, what is the status? This might be partially completed, 50% completed because one cycle runs. And this is the very first time. And this is like completed 10% or 20%. And in the other hand, this might be a process. P1 is a process from music, your VLC player. This process executes from your VLC player. And this one is from your MS Word processor. You know how to find these processes, right? I think you know, right? Do you confident about that? These processes, find in the processor, go to the processor details and other stuff. Go to the task manager and other stuff. I have shown you, right? Find in these processor related stuff. So these processes P1, P2, P3, and P4 likewise. This process P1 is from a VLC and process P2 is a Word from Word, and P3 is from like we'll get Excel. This one is from your IDE VS Code. So 4 different states are there. They have different objectives. As an example, VLC play has a specific objective to consume resources. What are these resources? Your hardware resources. What are the specific hardware resources? It might be a speaker and the monitor. It requires to consume these resources. So specifically, much process means much memory. Got the point? Any questions? Anything needs to clarify? Please don't keep quiet. If you want, ask any question. Ask any question. No worries at all. I really like to help you. You got this story? Clear? Detailed enough? Yeah, there's a question. No, there's not a question. It's yes, sir. Any questions? No, right? There are duplicate responses. Your previous in class activity, please don't duplicate. Please don't duplicate. There's no point to duplicate. It's a mess for me. All right, we'll go to the next point. Scheduler will decide which process runs. May different schemes to decide. Now, once it comes to scheduling, there's a component called scheduler. We'll see what is this scheduler. We'll dump the same story again and again. Now, there are a set of people, candidates are there. Set of candidates are there. Now, all right, there are 300 candidates. It's a big queue. 300 candidates are there. And here, this is the room, right? And there's a place, a security guard or a coordinator who is standing on it. A security guard or a coordinator, probably it's a coordinator, project coordinator. What he or she is doing, is asking, calling to the relevant person. All right, Anushka, please come in. Then this is the arrival order, right? You all sat in an arrival order. But for this case, there's a specific scheduling behind the scene. They have scheduled according to skills or some like CV arrival time or any other thing. Now what happens? They call to you, to Anushka. Anushka is sitting like here. Then Anushka stand up, go to here. Next, Amal, you come, right? Next, Amal goes to here. This can be happen, right? This can be happen. What's the job role of this person? Calling or coordinating. If we simply state it's a scheduling who is going to be next. So is this person? This person is a scheduler, right? It's a scheduler. Scheduling. Okay, you come next, and you come next. You go, you should be ready. You should be ready. Now here, this is the room. This is the place that coordinator stands on. Now next, all right. Anushka, you go next. You should be ready to the interview. Then Anushka goes to the interview. What's the responsibility of this person? Take the most appropriate or the relevant person into the interview. Extract same. Yes, no difference in the scheduler, the other words. When it comes to computer world, now you may able to explain. Anyone can explain the scheduler in the computer world. Can you map this real world with the scheduling in the real the processes scheduling process scheduler? Anyone needs to explain to the students? If you explain, you will get 10 points. So grab these points always. It's a golden opportunity to get a good result. Target for a plus. I know, you know, I personally don't believe marks are very valuable. I personally believe skills are more valuable than marks and these paper qualifications. But nevertheless, you should have a paper qualification too, right? So grab these points and marks, then you can show off, right? I am mastering this subject area. Yeah, anyone? 20 points. Come on, guys. 20 points. Don't miss this golden opportunity. Anyone can map. Don't worry. You switch on your mic and say, because no one can see, fortunately. No need to be shy. And in the other hand, you people are friends, right? You all are friends. You all walk together, run together, fight together. And even after the university, you people are the colleges forever. Though you are in US, UK, India, or many the countries, Singapore, wherever, regardless of the other friendships, this is the best ever place to have friendships. So not need to worry, not to be shy. Set of your friends, that's it. Yeah. Anyone can map the scheduler story with the computer operating system scheduler? Can't map. It's quite easy, right? Now it's quite easy. What happens here? There are processes like P1, P2, P3, and P up to Pn. There are three dots, which is very like three dots. It's a sequence or a series. So all of these processes are there. P1, P2, P3, and blah 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 blah. There's a specific component written in between the processes running and the CPU. We'll get a very high level. Right? I'm speaking very high level, but when it comes to detail, it might be much different approaches are there. This is very high level. Very high level understanding is more than enough for now. There's a component called scheduler. All of these scheduling algorithms, a little bit earlier, I told few algorithms, scheduling algorithms. Anyone can remember? Scheduling algorithms. Round robin. First come, first serve. So shortest job first. So these are the scheduling algorithms. All of these scheduling algorithms are installed in here. I mean, not all. The most appropriate algorithm will run according to the situation. If there's a very shortest job, set of series of shortest jobs are there, it behaves in different manner. Likewise, it executes in different manner. All right. So that's the behavior of this scheduling. The scheduler, the job role of a scheduler. I think you got the point, right? Any questions? Scheduler, clear? Process may run until allocated time run out. We'll go back to the ready queue to allow other processes to run. Now I'll back to the process diagram. Now here, one process comes into here ready. One process is ready to here, and it jumps into running. P1 is going to be run up to 1 millisecond. 1 millisecond it's going to be executed. But unfortunately, this P1 is a very lengthy process. It requires 10 milliseconds to execute. 10 milliseconds to execute. So it jumps to here, it runs 1 millisecond. After the 1 millisecond, ending of this 1 millisecond, what happens? It goes back into the ready queue and await. Timeout. This is the timeout. Right? It's timeout. You have only 1 millisecond, it's timeout, so you can't execute furthermore. You just join to the ready queue again. Now, how much time this P1 process needs to be in the queue? We don't know. We don't know. It depends on the number of processes in the queue. Now, as an example, if there are like 1 million processes are there, we don't know what happens. Somehow, the logic is P1 remains 9 milliseconds to be executed. We'll get the best case. Fortunately, there's no any process at the moment. This is the only process. It's like ultra super case. We'll get an example. Fortunately, we don't have any process. This is the only process. So what happens here? 9 milliseconds. So it jumps back again. So the 1 millisecond executed. This is the second time. So 1 millisecond executed. Totally it's milliseconds executed. 1 millisecond in the first round, second millisecond, second time 1 millisecond. So altogether 2 milliseconds executed, remaining 8 milliseconds, right? 8 milliseconds. Then back again, it moves to the running state. Now it requires to execute 8 seconds, but unfortunately we can allow only 1 millisecond. So it executes another 1 millisecond. Totally, it executes now 3 milliseconds. The remaining 7 milliseconds go back into the ready queue. And it moves to the running state again. So altogether now 4 milliseconds executed, remaining is 6 milliseconds. Likewise, it's executed until there's nothing to execute. Now you might wonder why it's jumping here and there, right? If there's no process at all, it's jumping here and there. It moves here and moves here. Back and forth, it's running. No point at all, right? So the best possible is run this lengthy process at a glance in the first time. Isn't it? Any arguments? Do you got the point? ඔයාලට තේරෙනවද මම කියපු දේ? මේ process management එකේ කියපු දේ තේරෙනවද ඔයාලට? මේ process එක මිලි තප්පර 10ක් run වෙනවනේ. මේක මිලි තප්පර 10ක් run වෙනවා. ඒතකොට මේ මිලි තප්පර 10 run වෙනකොට මෙයා 1 මිලි තප්පරයක් තමයි run උනේ, execute උනේ. ඊට පස්සේ ආයෙත් මිලි තප්පර 9කට මෙයා ආයෙත් මෙතෙන්ට එනවා. ආයෙත් මෙතෙන්ට execute වෙනවා. ඒතකොට මිලි තප්පර 10 ගානේ මිලි තප්පර 1 ගානේ 10 සැරයක් මෙයා run වෙනවා. ඒතකොට මෙයා මිලි තප්පර 1 ගානේ 10 සැරයක් run වුණාම තමයි මේ වැඩේ ඉවර වෙන්නේ. ඒතකොට ඔයගොල්ලන්ට argument එකක් එන්න ඕනේ. Why the computer, the operating system is doing this kind of like, it's not an intelligent process, right? It's very like what we call no point at all. It's like damn unwanted story. අවශ්‍යම නැති වැඩක්, isn't it? There's no point at all to execute such kind of thing, isn't it? Any arguments? ඔයගලන්ට පැහැදිලිද මම කියන දේ? Clear? Is that clear? You know, this is, you should clear it out, unless you might spend hours and hours. Little bit what is the point that you didn't get? Unless you have to spend hours and hours, Puta, you know, it's like damn hard to understand what happens in here, especially like for a beginner like you. But you didn't get. Now I'll go one more time and I'll try to explain it again for you. Now here, a process called P1 jumps into the here. This is a process P1 and it starts to running. This process, to execute this process, it requires 10 milliseconds. How much? 10 milliseconds. But in the running state, it can stay only 1 millisecond. It can stay maximum only 1 millisecond. So here, to run this process P1, if we allow in the running state to 10 milliseconds, we'll take running state allows 10 milliseconds. No worries at all. This P1 jumps into the running state, it runs 10 milliseconds, and it moves to the dead. That's it. No worries at all. I think that's clear. Now we'll get another situation. Now here, in the running state, it's not allowed to have this 10 milliseconds. What happens? It allows only 5 milliseconds. This running state allows only 5 milliseconds. Only 5 milliseconds. Now what would be happen? There are 10 milliseconds to be executed, but once it comes to running, we can't execute 10 milliseconds. We can execute 5 milliseconds. So what happens? 5 milliseconds it's executed, then remaining in subtract by 5, remain is 5 milliseconds. So what happens to these 5 milliseconds? It moves back into the ready state. That's the name of this timeout. This is like timeout, because there's no time, 5 milliseconds only allowed. Now, once it back into the ready state, how much time it needs to execute again? 10 milliseconds? Can you raise your hands if you believe it's 10 milliseconds? Quickly, I want one answer. How many of you telling it's 10 milliseconds? Raise your hand. I think you can raise your hand. Ten milliseconds. 5 milliseconds. Please raise your hands. 5 milliseconds. The remain is 5 milliseconds. Quickly raise your hands. You can't raise your hand. Yeah, one guy raises the hand. Two. Quickly. How about the others? 3. No need to be shy. If it is wrong or correct or wrong, who is going to be die? Don't worry. Only 3 guys. What are the other answers? What are the other answers that you have? If you are not raising hand, you should tell your answer. I'm going to speak randomly for people. Yeah, one guy removed. Come on, it's 5 milliseconds, right? Because initially there was a 5 milliseconds process to be run. And in the processor, once it comes to running state, 5 milliseconds run. So remaining 5 milliseconds move back to the ready state. So now it's just a 5 milliseconds process. It's just 5 milliseconds process. Now we'll get assume it's like another chance comes into here. You got this P1 process got another chance. Now what happens here? We can run up to 5 milliseconds. No worries at all. So it moves to the running state, and it moves to the dead. Got the point? Got the point? Shall we check your understanding? Again, you might have this opportunity to get 5 points by answering this in-class activity. In-class activity 1. Yes, any questions? Yeah. There's a question like A levels, we learned that reason a process moves from ready to blocking or waiting because it's lacking, right, an input, or because like input or not having enough memory, or another reason. Is that the same thing I'm explaining? Obviously yes, right? The difference is let me show you the difference. Now your A levels, is there guys from IT have learned IT? If I'm not mistaken, maths and commerce, right? Any IT guys here? Actually, there's a question. This is a bit complicated. Obviously, yes. The subject is complicated. Obviously, yes. Too hard to understand. Obviously, yes. No arguments at all. Even if you go to any other place, even if you go to your IT guys or engineering guys, computer science guys, you may ask the question, how about Machang operating systems? They'll realize, oh, Machang, it's damn shit. It's really hard. That's the answer. I'm pretty sure. This operating system subject is quite hard. It's obvious. This is the nature. Right? This is the nature. The subject, the understanding. All right. If you are from IT background, like your A levels, if you have done IT, there's nothing. I'm pretty sure you got the story because you have learned these processes and other stuff in your A levels. It's obvious. So it's not something hard to understand. It's quite easy to understand what happens in this process management. But in any sector, like no combinations, then it might be quite hard to understand. That's obvious. It's not something for only for you. So you should give some good effort, high effort for this subject area, unless you might be unable to understand. That's really that's a reality. It's obvious. Yeah, probably right. We'll see. Right. I try to level best right to explain what happens in here. I can't change the language because there are some. I can't change the language actually. I'm really sorry. I can't. Yeah, but Sinhala I can teach in Sinhala, but once it comes to university education system, you have agreed to learn in English medium, right? And the other hand, there might be some Tamil guys who can't understand Sinhala, so it's unfair, right? So somehow good. Uh, I know few of you at least understood. All right. For back to the question that one of student asked. In your A levels or somewhere, you might heard like because of IO waiting, input output waiting until the resources are coming, the computer getting stuck or awaiting the processor is awaiting. Yes, that this is the path of that. This is the path that you learned in A levels. But once it comes to A levels, I don't think so. You have discussed this timeout and other stuff. I'm speaking. We have sufficient resources, but unable to execute because this processor has a specific time limit. It might be 5 milliseconds or 10 milliseconds or something. It's predefined. That's the case I'm speaking now, but it's always back into the ready queue. It's always back into the ready queue. All right, clear? We'll do a question, then you might get much understanding. In class activity 1. P1 processor. Let me share the. Yeah. You may able to understand after completing this activity. I have shared a question. Could you please start it? I think It's quite easy. Question is quite easy, but if you got a little bit confusion after completing this activity, you might get able to understand what happens in here. Importantly, if you haven't go through the last or the previous lecture, if this is null or nil or empty, your brain is empty with the process and other related stuff, the process diagrams and other stuff, if it is not in your head, you can't understand. That's obvious, 100% sure. A student who is nothing, who can't remember anything what happens in the last session that we have learned, I'm pretty sure you can't understand what I'm speaking today. And it's a series, so if you don't know the first one, the second one, and third and fourth, at the end of the day you can't understand anything. That's the reality of this operating system. That's the nature of this subject. This subject is quite hard, again I'm telling you. So don't back with the question, so it's hard. Yes, obviously I know that, right? So we'll try to smooth it, and you give the maximum effort from your end, I'll give the maximum effort from my end too, right? Start answering. I'll give around 5 minutes. I don't think so you want 5 minutes, but we'll see. And importantly, you'll get additional 5 points for your assessment. Start.